Hey guys, Mr. Golis again. Alright, I'm going to do a quick lesson that is testable material, but it's easy material. It's actually on page 53 in the Barron's Guide. Kind of looks like this. I can't get this thing straight on this camera here, but whatever. And it's on what are called the 7 big ideas that the AP exam wants you to know. Alright, there are more than 7 big ideas. Right, in physics, but for some reason the AP exam picks out 7 of these things. All right, I'm just going to talk about them. First one is that if you take a look at it, all right, with and you might want to get your book out while I'm talking here, but it's on page 53. But big idea number 1 is that objects and systems have properties such as mass and charge, and systems may have an internal structure. Okay, that's pretty obvious. All right, this is an object. This has what makes it an object. Well, it has properties such as mass, right? If I put it on the scale, gravity will pull on the mass and it'll appear as weight to me. All right. It might have other properties, like for example, it might have some charge to it, electrical charge. It might be positive, might be negative, it might affect other things around it that have charge. Okay. It has density. It takes up some space and it has some mass. So this is a particle or an object, okay? And they have properties. So we kind of got that. All right, that's number 1. All right, number 2, fields exist in space and can be used to explain interactions. Okay, great. I love playing with these things. I don't want to get them too near the computer. But these are neodymium magnets. And there are these things called fields, all right? And what that means is that some objects do something to the space around them that creates an effect on other objects, okay? Like for example, these 2 magnets, right, create a magnetic field around them. I'm trying to push them together. They're so strong, can't even do that, all right? You do this, look at that. There's traction there. The magnetic field of these objects causes them to attract each other. They have the property of magnetism. All right. This object is doing something to the space around it, so that if I put another object with the property of magnetism near here, a force will be created on that object, and it will be attracted or repelled. There are different types of fields. This is a magnetic field. There are electric fields, gravitational fields. You're in one right now. You're born in one. That means that the planet is doing something to the space around the planet that causes everything that have mass to be attracted to it. All right? And we call that space where the force can be felt, we call that a field. And fields can explain interactions. For example, some right here, 2 objects touch, and you say, well, these 2 objects are touching. No, not really. This object here, nothing ever really touches anything per se. This object here has atoms, okay, on it, and those atoms have a nucleus that's positive, and it has electrons flying around it. And so on the surface here, basically it's a surface of electrons. They're kind of bound to their nuclei and all that, which are negatively charged. My hand, made of atoms, also has negatively charged electrons on the surface of it. When I get really close, what winds up happening is the 2 negatives here and the negatives in my fingers, repel each other. That's really what's going on. It's an interaction between 2 electric fields. It's a repulsion between 2 negatives. Now, so close, doesn't really even matter. No, you can't use that as an excuse if you punch someone. Hey, I didn't really touch him. It was really the negative field created by the atoms or the electrons in my hand that was repelling the negative atoms in his face. So I didn't do anything. Well, the judge isn't going to buy that, but regardless, fields explain interactions between objects. So we have that, and that's number 2. Number 3, the interactions of an object can be described by forces. All that means is that fields, which cause interactions, create these entities called forces. If you're in Physics 2, you know what that is already. If you're in Physics 1, we'll talk more about that later. A force is something that changes what an object is doing. If it's moving, it changes how the object moves. A force speeds something up, slows something down, or turns it. If it's not moving, then it causes the object to move, and that's what a force is. Okay, so forces also explain interactions. That's number 3. 4, interactions between systems can result in changes in those systems. This is a group of atoms acting together. This is a system. Another group of atoms acting together. It's a system. When I hit them together, now I don't have the equipment to measure it, but really what happened is the kinetic interaction here literally raised the temperature of this object, or the surface of it here, probably about 1,000th of a degree or something like that, but it changed the system. Okay, so when systems interact, changes can happen to those systems, right? And that's number 5. Okay, number 6, those changes that happened in the system are constrained by something called conservation laws. Okay, in nature, certain things are said to be conserved. All right, what does that mean? The biggest one is energy. You've probably heard this before at some point. Energy can neither be created nor destroyed. Okay, so nature has certain constraints that when interactions happen, the energy going into the interaction, okay, is the same throughout the whole interaction. Okay, that doesn't mean it doesn't change. Now, when I do this, you heard it. That sound didn't make itself. That sound is energy being carried away from this interaction. Okay, so I gave it some kinetic energy. A collision happened, and sound was made, and the energy leaked away. And also the temperature of the object rose, so some of the energy went into that too. Okay, so the energy in that interaction is conserved. We'll talk about it now in Physics 2. You also know about momentum. All right, that's another kind of property that's conserved in interaction. So the momentum before collision is the same as the momentum after collision in a total enclosed system. If you're in Physics 1, you'll learn about that later. The concept of conservation of momentum. Right? It's also conservation of angular momentum also. If you're in Physics 2, you know we talked about that last year. That's what happens when a figure skater is pirouetting and she closes her arms and she speeds up faster. Physics 1, you'll learn about that later. Okay? Number 6, waves carry interactions, all right, or carry energy from one place to another. You hear the sound. How do you hear the sound? Part of that energy is carried away from the reaction in terms of a sound wave. Okay, and so the interaction happens. The atoms vibrate. They hit some of the atoms in the air. The atoms in the air picked up that vibration, which means they picked up some of the energy from those atoms that were hit, and they carry it away, and we hear that as sound. You also know that energy is carried through waves because we live in the ocean state. Wind blows along the water, it collides, the air molecules collide with the water, cause the water to wave up and down, and that energy is carried away. You know this if you've ever been hit by a wave. It can be quite a lot of energy in there. All right? So light is also a wave, and that carries energy too. And that's from the sun 93 million miles away. Okay? So waves carry energy. That's big idea number 6. Okay. Big idea number 7, really more for Physics 2, is that probability in the world of really small things, which we call the quantum world. So when you get really, 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 really small in nature, like to about the size of an atom or smaller, the traditional laws of physics kind of break down, and that really requires kind of a little more of a lesson explanation because it's not very intuitive. It's not very commonsensical because you're not that small and you're really in life don't have quantum interactions at your level. So so there's that. But at the really, really small level, interactions are governed not so much by traditional laws of physics, but by probabilities. And that's something you need to know. We'll do a whole unit on that towards the end of the course. All right? Okay, so for now, just know your 7 big ideas. Those are testable materials. You might see hint on a test or quiz. What's big idea number 2 or something like that? Or what's a conservation law or something like that? Okay, so that's kind of fair. Alright, so study this, take notes on it. If you have questions, ask me during academic lab or after school. Alright, goal is out.